Welcome to Ask and Learn.
Hello students, here we need to determine the difference in surface area between the human brain and the mouse brain. Let's denote the human brain, that is the surface area of mouse brain, as A mouse and that of the human brain as A human. Now it is given that the human brain has 1000 times the surface area of mouse brain. Therefore, A human will be equal to 1000 into A mouse. Now let's introduce a factor, that is lambda, which refers to represent how much larger the surface area of the human brain would be than the mouse brain. So if human brain was not convoluted, in other words, if both brain has the smooth non-convoluted surface, we can express this as A human non-convoluted will be equal to lambda into A mouse non-convoluted. So here we need to find out the value for lambda. We already know that the value for AH is 1000 times of AM. Now we can assume that the convolutions in human brain increase its surface area by a certain factor, that is K, which is greater than 1. Therefore, we can express A human will be for the convoluted will be equal to K into A human for non-convoluted, and A mouse for convoluted will be equal to K into A mouse for non-convoluted. So let's substitute the expressions for both and find out the values. Hence, A human is equal to K into 1000 times of AM, and AM will be K into AM. Now we can express a ratio of surface areas of the convoluted brains. Therefore, A human for convoluted divided by AM for convoluted will be equal to K into 1000 into A mouse divided by K into A mouse. Here, both the K values cancel out, and also the AM values get cancelled out. Hence, we can say that A human for convoluted by AM for convoluted will be equal to 1000. So this means that the surface ratio of the convoluted brains is 1000. So the factor lambda by which the surface area of the human brain would be larger than the mouse brain if brain was not convoluted. So in summary, we can say that if the brain were not convoluted, then its surface area will be still be 1000 times larger than the mouse brain, as it is shown with convolutions. Hope you find this video useful. Thank you.